Hello, my virtual friends. It is May 7th, and today in this math lesson, we're going to talk about percent error, which is a really great real life skill that you can start to master in seventh grade. You're going to use this a lot when you get into science. And if you choose to study science in college, you'll talk a lot about error. So I'm excited to dive in with you today. And I am feeling so proud of all of your hard work on percentages. This is something that traditionally and within the school year was one of our topics that that really challenged us. And so I'm excited to get to practice it again. And I really respect and admire your hard work on percents this week. I want to start by just explaining what percent error is. It is a number that compares an estimate for some value or a prediction of a value to the actual value. So let's say, for example, you are expecting a baby brother. Maybe you predict, or the doctors predict, how much that baby will weigh when he is born. And then you can actually weigh him when he is born. And you might be wondering, by what percent of the actual value was the estimate off by? Okay, this is a helpful measurement for a lot of reasons, but you can continue coming back to this slide in this question. By what percent of the actual value was our estimate or our prediction off by? I do want to give an example to try and show why percent error is a helpful calculation. And the reason I want to do this is not to convince you that it's important, but actually to help you remember how to calculate it, okay? But also maybe I'll convince you it's an important calculation too. If you were wondering how many people live in Phoenix, you could do a few things. You could count all the people yourself. That would take a lot of time and resources and probably isn't safe to do right now. You could look it up, you could do some research, or you can make an estimate. If I asked you to estimate how many people live in Phoenix, what would you say? Okay, I want to show you my estimate. I estimated that there were 1,500,000 people in Phoenix. You'll hear, when you hear on the news or when you read an article, often people will kind of round to a nice number with a lot of zeros because big numbers like that fluctuate a lot, right? So 1,500,000 people in Phoenix, that data was from the census in 2010. However, the census in 2010 actually showed there were exactly 1,445,632 people. So was my estimate correct? No, my estimate was not correct. However, I'm wondering how close was I? Okay, so in order to answer that question, how close was I did two things. First, can't see this whole thing. First, I counted by how many people I was off by. So my estimate was this 1.5 million. And I subtracted this 1,445,632, and I got, wow, I didn't count 54,368 people. That sounds like a lot of people, 54,368 people. That's a really big difference, right? But if I look at it in terms of percent error, that's only 3.6% of the population. So less than 4% of the people I didn't count. But the other 96% of people I did count, right? So that percent change actually makes that error look small and really puts that in the context of population. Let me give you another example. When numbers are really small, percent error can be helpful too. So let's say, for example, I have 40 students submitting assignments in seventh grade every day. Maybe I make an estimate that 35 of them will score in the green on their assignment. They'll do really well and they'll score proficient or advanced, right? If actually, instead of 35 people like my estimate, if actually only 10 people scored proficient, my estimate was off by 25 people. 25 people is not a lot in the population of Phoenix, but it is a lot in the context of my class, which only has 40 people total. So that percent error would be a lot higher because my total got smaller, okay? Percent error overall helps us understand our error or how far off we are within the context of the problem as a whole, okay? That's why it's so helpful. I think those examples are helpful for remembering the procedure to find percent error, and that's what we'll talk about next, okay? This is a great time to check and make sure your notes are set up and ready to go. We'll probably want to take some notes on how to find percent error now. So go ahead and grab a pencil and paper, set up your math notes for today. If you need a little bit of extra time to gather those materials, go ahead and pause the video to do that now. Awesome. Let's talk about how to find percent error. Here's what you're going to do. You can find the amount of error using subtraction. So subtract the actual amount and the estimate. So if the doctor predicts that a baby's going to weigh 8 pounds, but the baby actually weighs 7 pounds, what's the amount of error? Yes, 1 pound, right? The estimate was off by 1 pound, okay? And that can be in either direction. Your estimate might be a little bit too big or a little bit too small. Either way, use subtraction to find the amount of error, okay? Once you have the amount of error or how far off your estimate was, you just want to find what percent of the actual measurement or the actual amount the error is. Okay, so our actual amount is like our whole or our original, and it represents 100%. This second step is what we've been doing since Monday. We've been finding percent change, new amounts, original amounts. Today we're finding percentages of the difference out of the actual amount, okay? So in my baby weight example, the error was 1 pound. I think I said the actual weight of the baby once he was born was 7 pounds. So I want to know what percent of 7 is that 1 pound error, okay? I put a few strategies here. These are my favorite strategies for solving percent error questions. Ratio table, you guys are crushing it at ratio tables. We can still use that to find the missing percent. We just need to remember that the actual is the whole. And so when we put in the actual in our table, we line that whole up with 100%, right? That's hard to see. Okay. You can also write an equation. If you want to write blank percent of 7 is 1, you can do that. I think this might be the trickiest strategy for me personally, but if you're strong in algebra, that could be a good one for you. And then a really quick way that I love, and I think some of you are going to love, is actually I can write a fraction of the error out of the actual and then convert that to a percent. Okay, so this is great if fractions are your thing and if you have access to a calculator. Okay, by the way, it is totally fine to use a calculator on this standard. So go ahead and grab that if you would like one. Let's do a practice question together. Okay, I put the same notes here, so if you couldn't get everything down before, you can pause the video here and copy down a couple of notes. All right, guided practice number 1. Isabel thinks she has space for a 45-inch wide bookcase. Okay, so thinks, that's her estimate. It turns out she only has space for a 40-inch wide bookcase. What is the percent error in Isabel's measurement? Awesome. So the first thing that I want to do is I want to identify some important information from the question, okay? I'm going to try. I'm going to try putting both on my screen. We'll see if it's working. Okay, that's close enough, right? All right. Thanks for being patient. So some important information from the question. This is guided practice number 1. I'm going to write that her estimate is 45 inches. Okay, that's important for me to know. And then I also want to know what her actual is, The actual amount of space she has is 40 inches. Okay, so when I'm thinking about finding the percent error, the first thing that I'm going to do is find the amount of error. So how much was she off by? I do that really quickly by subtraction. I know you can do this in your head, but I want you to write it because you won't always be able to do it in your head, and it's going to help you understand and memorize that procedure. Okay, so let's find 45 minus 40. Of course, that's 5. And I'm going to label this is the amount. Oops. I'm just going to write amount of error. Okay. Again, I know you don't have to write that in order to solve it, but it's going to help you remember that procedure. So please write it down. Okay, then once I have the amount of error, Isabel was off by 5 inches, I'm wondering what percent of the actual amount of space she has is her error, 5. Okay, so I'm going to find what percent of the actual. I'm going to show using a ratio table first because this is a strategy that you guys are crushing. And so I want to make sure you have it in your tool belt. Let's go ahead and set up a ratio table, percent and value. I'm going to start with my whole, 100%. Remember, that's not given in the question. I just have to know that the actual amount is the whole, and so it represents 100%. The actual amount goes here in value. The actual was 40. She actually has 40 inches of space for her bookcase. Okay, so the only number in the question was 40. Remember, I'm bringing that based on my own knowledge. I want to find what percent the error is. The error is 5 inches. I want to find what percent. My answer will be here. Use any strategy to find that missing value. 15 seconds left. Did you get it? I know that 40 divided by 8 is 5, and I know, this wasn't a fact that I know, but I've done so much percents now that I've got it. 100 divided by 8 is 12 and 5/10. So what is the percent error? I'm going to go ahead and write that answer in a sentence. Go ahead and write with me. Her percent error was 12 and 5/10%. Excellent. I want you to try one now. Again, you can use the ratio table or you can try one of these other strategies. I will show another strategy on the next one. So if you're not sure about these others, that's totally fine. Use a ratio table. Okay, here's question number 2. I want you to read it and then answer that question. 1 minute, go. First step, just jot down that key information from the question. What is the estimate and what is the actual? All right, whoops, I don't want to watch that on YouTube. Let's go ahead and come back together. It's okay if you didn't quite finish. All right, here's my work so far for number 2. I actually didn't get to finish either. but we'll finish together. The estimate of the amount of rainfall was 3 inches. However, actually it rained 4 inches. So to find the amount of error, I subtracted. The amount of error is 1 inch. The estimate was 1 inch off, okay? I want to show you this strategy, write a fraction and then convert to a decimal. Can you make this note on your paper so that you have this strategy on your independent practice today? I think it's way faster. So if you can add on this strategy into your tool belt, that could be helpful. This strategy works anytime that you want to find the percent. So if you're given the original and you're given the change and you want to find the percent, this strategy works really well. Percent change is the percent that the error is of the actual. So I'm going to go ahead and divide the error by the actual. Okay, remember my fraction bar represents division. Represents? Yes, my error was 1 inch. What's my actual? Yes, 4 inches. What is 1 divided by 4? Yes, 0 and 25 hundredths. What is 0 and 25 hundredths as a percent? Yes, 25%. Her percent error, or his, I don't know, was 25%. Okay, pause here to update your paper if you need it. We're going to do one more question together. And in that question together, you can feel free to use this strategy if you would like. Okay. Awesome. Question 3. I want to read it together and then give you a full minute just to work. Okay. Hans estimated the length of a front yard to be 15 feet long by counting strides. Stride is a step, so it's just saying how he made his estimate. Okay. The actual measurement of the front yard was 23 and 5/10 feet long. What was the percent error of Hans's measurement? Round to the nearest whole percent if necessary. Awesome. You choose the strategy. I've shown you ratio table and this last one, write a fraction. You could also write an equation if that is more your speed. You have 1 minute to do that. Go. We are about halfway through our time. Make sure you've selected your strategy at this point, and you're either setting up a fraction or you are setting up a ratio table. Okay, if you want a little bit of extra time, please pause the video here and take that extra time. If you're ready to check, here we go. All right, folks, my percent error was 36%. Did you get that? I hope so. I'll put a big star next to it on your paper if you got it. Just quickly, I used the write a fraction strategy. The error was 8 and 5/10. I got that by subtracting. The actual was 23.5 feet. I did division. I just used my calculator. You're welcome to do that. I got a decimal that wasn't nice. It wasn't like question 2 where it was a terminating decimal. However, that's okay. It told me to round to the nearest 1 whole percent. So I like to leave a few extra decimal places here so I know how to round later. When I multiplied by 100, I ended up still with 2 decimal places. I'm rounding to the ones place, so I look to the right and no, it's not closer to the next one up, so I'm going to keep it at 36%. Okay? Excellent. Great work today. That is all of our guided practice questions for today. I didn't pause you throughout the video to answer the questions in your Google form, but I want to do that now. In each of your Google Form questions for guided practice number 1, number 2, and number 3, I want you to write the answer we got. So what percent error did we find in question 1, question 2, and question 3? Okay, just type, like number 1 was 12.5%, just type 12.5% and use that percent key, which on my keyboard is on number 5. Okay, so shift 5 will give you that. Sweet. To do today, your independent practice, because it's Thursday and we've reached the end of our week, is a quiz. So before you start your independent practice, go ahead and gather all of your notes from this week on percents so that you have them while you're taking your quiz. Remember, it's okay to use a calculator as well on your quiz today. You have your skill builder for a couple of quick practice questions. And just a reminder, please go to office hours today at 3:15 if you want to clarify a question on your quiz or you want to get some of the problems set up correctly so that then you can do them on your own. Please do that. I know Ms. Russell would love to see you there, and you can get some Vista Virtual points for doing that. Just a reminder, when you submit your Google form, if you click this View Score button, it's going to grade your video questions right away. So you should see a score of 3 out of 10 right away. The other 7 points come from your quiz and your skill builder, and we'll add those in later. You'll see them tomorrow in Google Classroom, okay? Also, just a friendly reminder that Sunday is Mother's Day. So if you would like to celebrate your mom or someone in your life who loves and takes care of you like a mom, go ahead and plan something nice for them on Sunday. Make a lovely card. That's it for me. You guys have an awesome Miss Terribly. See you here tomorrow. Bye.